Hey, we're Group 14 for Magna mirrors, and we are creating a trailer toe manual efforts tester. So what this machine does is measure the amount of force that it takes to extend and retract a mirror while measuring the distance that it goes. So over here we got the jack that accommodates for different mirrors programs, and we got the A-frame to mount different biplates too. So what we have here is something called the locator plate that helps out with making all the mirrors align straight with the actuator. So since this is a DJ left hand, we're going to rotate this 90 degrees and spin it until the mirror gets straight with the actuator. Put in the pin in the hole here, and we're ready for the second part of the test.
Once the mirror is locked into the rotation position, you can use the ratchet strap here to securely lock in the head for extension, and this L bracket here allows for any retraction of the mirror. And we have this bottom plate on the L bracket that touches off on the bottom of the mirror head just to ensure for the different programs. And then coming back here, we have a load cell in this 3D printed case that allows for the force to be measured. And down here we have an IR sensor that measures the distance during the extension and retraction of the trailer toe mirrors.
And then moving on to the actuator here, we have it sitting on two linear slide rails, one in the front, one in the back. And now what they do is they allow the actuator to slide side to side. Obviously it's ratcheted down right now. And then we have two set screws, again, one in the front, one in the back, that stop the actuator from being able to move side to side. And it locks it down for when we're pushing and pulling on a mirror.
The machine is controlled by a Raspberry Pi that takes the inputs from the IR sensor in the load cell and has an output of the actuator. Here is the main user interface for the machine, where a person can select the mirror, start, forward jog, reverse jog, and add a mirror as well.